Hi everybody, once again you are welcome to my YouTube channel. This is Ropo Digital and Marketing YouTube channel where you learn about data analyst, you learn about digital and marketing analysts with tools, learn about Power BI, learn about Looker Studio, learn about Google Analytics 4, learn about dashboard creation using Excel, Power BI, and Looker Studio. Learn about Google Ads campaign. A complete analyst. In the first video, we talked about data preprocessing part 1. In the second video, we shall be talking about our data preprocessing part 2. In the part 1, we did some justification where we import our libraries and we import the dataset because we want to predict which of the country that bought the product from a reputable company. So, and after that, we clean the data because we have some missing data, some NaN, which is not a number. Then we have to also encode the categorical data in order for us to be able to predict our machine learning model very well. So as I've said in the part 2, I said we'll be splitting the data sets into training and test set because we will be predicting machine learning model and we have to start from somewhere before we get to that. So now we'll be importing the library that we need, splitting the data set into training set and the test set. So we are also going to be using our scikit-learn as usual. So from scikit-learn, we are going to make it from scikit-learn.model. This time around going to be model selection. From scikit-learn.model selection, we are going to import. We are going to import train test split. Train test split. So that is what we are going to import first. Then the second one that we need our S-train. Then we need, this is Z. We need our S-train. We need our S-test as well because we are separating them. Then we also need our Y-train. Then we need our Y-test. So our Y-test. So once we get our Y-train, we get our S-train, we get our S-test, we get our Y-train, our Y-test. Then what next is we are going to make this equal to train test split. That means we are going to make everything to be this. Now, as I've said in the first video, I love to copy, so you can just copy and paste instead of you retyping, but you just have to be careful so that you will not have some errors. Probably that might be some errors in your first typing that you typed. So we are having our train test split now. Then we are going to have in a bracket, we are going to have our X, our Y, because already we are going to separate our data. We are going to have the train data and we are going to have our test data because we can't use all the data alone. We can't just train the data alone. So we have to have some test and we also have to have some training data. So we have our X, Y, then we're going to have our test size because what percentage of the data do we really want to use for test So that is what we by test size. So we are using is 0.2. Where some might use 0.3, which is we are using like this is 0.2, we are using 20% of the total data for test. Then we are using the remaining 80% for training set. Why we are using the 20% is because we don't want to make it 50-50. We don't want to make it 50 train, 50 test, because we just have to use a little part of the data for test. So let's see how our prediction will actually look like. So then we are going to use random states. So make our random state to be equal to 1. You can also make your random state to be 0. It doesn't matter, just that you want an equal something. Probably you want it -3 to +3, or you want it from -2 to +2, or you want it from -1 to +1. So we just want an equal something. So that is why we are making our random state to be equal to 1. Then what do we do now? Let's run it and see if everything we did here is right. We can just make a space here a bit. So let's try to run it and see if everything is correct. Yeah, good. Everything is correct. Then I think let's print our string and let's see our string. Right, look like print string and see what is in there. Yeah, we have our string already. Then we also have to print our s test to see what we have there in as well. Print s test. Then we have our s test to be this. Then we are going to print our y train. I can just copy the string here and just make it, just change it and make it y easily. So we have our y train already. Then we have to also have our y test. Then instead of I will just try to copy the s tests and make it a y test. So just as simple as that. So now this is what we have. Remember, we already split our data into training sets and data sets. So what we are having here, this our white train based on this, and this our white test also based on this. We are having our real number here, then we are having our also really predicted number here, which is, remember in the first lecture we have no, yes, no, yes, no, which is categorical. Then we have to encode it for us to have it as a number. That's why we're having 0, 1, 0, 1, 0, 1, 0, 1. So this is dependent on this, and why this is depending on this. Now we are going to apply a future scaling, and the future scaling we'll be using is we are going to be using standardization. You may ask, why should we use future scaling? Some people might ask, should we apply future scaling before splitting the data, or should we apply future scaling after splitting the data? Well, to me, I would say it is better for you to apply future scaling after splitting the data, because when you apply future scaling before splitting the data, that means there's going to be a data leakage. Your test set should be something you are not going to use, because it's something that should be secured, because you're just going to use 20% of it as a test. So, and if you already apply future scaling in it, I think that would be a data leakage, and we might not be able to get the accurate prediction of what we need. And then what about the purpose of, well, some people might ask me, what is the purpose of training and the test data? Well, I will tell you that the purpose of training and test data, the way training data is used to train the machine learning model. The more training data the model has, the better it can make prediction. So testing data is used to evaluate the performance of the model. So we are using our test data to evaluate the performance of the model so the model can learn from the training data and improve its prediction. So this is the reason why we are splitting our data to training sets and to test sets. Then what about fusion scaling? I told you in fusion scaling we have standardization and we have normalization, but I decided to use standardization. I will tell you why I'm using standardization, and I'll also explain normalization to you. Then what is data normalization? Well, one of the most popular methods for preparing data is normalization, which enables us to alter the value of numerical columns in the dataset to a standard scale. Normalization is the method used to arrange the data in a dataset. So this is what we use to arrange the data in a dataset. So it is a scaling method that reduces duplication, in which the numbers are scaled and move between 0 and 1. So when there are no outliers, since it can't handle them, normalization is employed to remove the undesirable characteristics from the dataset. So, but in the case of standardization, well, to me, I'm using standardization because standardization often referred to as z-score normalization. Occasionally is a method for rescaling the value. So it's a method for rescaling the value that meets the characteristics of the standard normal distribution while being similar to normalizing it. So standardization is crucial because it enables reliable data transmission across various systems. So you can see the difference now. It will be easier for computers to exchange data and communicate with one another with standardization. Additionally, standardization makes it simpler to process, analyze, and store data in a database. So businesses can use their data to make better judgments with this method. So that's why I'm using standardization, because I can use it in standardization is what you can use anywhere, and which to me is more better than, I would say more better than normalization, but because you can use it all the time. So I think that is why I prefer using standardization. And what is the form of standardization? So we are having our S stand is what our S mean divided by standardization by standard deviation. So we are having the total of our X, then we are dividing it by the standard deviation of what we have. So that's why I decided to put the formula there. So we are going to, now the question is, okay, I've explained why should we apply standardization and before scaling before splitting or after splitting. I've explained this, we have to apply functional scaling after splitting the dataset because of data leakage that we have to prevent from the our test set. That is why we have to use functional scaling after splitting the data. So we import from scikit-learn. So we are still going to be using our scikit-learn. So from scikit-learn, this time around is going to be preprocessing. From scikit-learn.preprocessing. So we are going to import standard scalar. So import standard we are going to import standard scalar. So what we just do is we abbreviate our standard scalar, pass a variable to it. So we have our SE equal to standard scalar. So we don't have to pass anything inside. So that is enough for that. Then what we are going to have is we take our S string. Let's come here and we can easily copy without any problem. Is better. To me, it's more faster than typing. So we have our S string here. Then we are going to pass it in. Now I'm going to explain some things to you here. What we need is the all column, or you call it all. So we are having all of this. Remember, when we come to this place, already this is already in what we want. So we don't have to scale this any longer, because when we scale this, definitely we are not going to have a very good prediction. So we only need to scale this and this. And when we go back to our data sets in the beginning, we will see that these are the, we are having our, this is the country, let's come here, this is the country, age and salary. So already we've already encoded the country. So this is the age and also the salary that we apply the function scaling, because we want to scale everything to make it equal. So this is what we are using. So this is what we are using. So that is why we are having it to be all. Then the next thing is going to be, we are having from the third row. That means we are having it from here. So that is why if we are making it 2, definitely we might include the one we don't have to. So we only need this and this. So that is why we are making it 3. And that is only what we need here. Every other thing is absolutely okay. So we don't have to add any other things to it. Then we make it equal to, then we have our SC here. So we have our SC dot fit transform. So we are going to fit and transform the data. So what are we fit? What are we transforming? We are transforming our string. So we can easily make everything here. This is what we are transforming. So we have it here. You can easily copy and have it here. So we are transforming our string. So transforming our string, that is what we are doing. Then after transforming our string, then don't forget also we have our s-test. But in the case of our s-test, we don't have to fit our s-test. We only have to transform the s-test. So that is the only thing we need for the s-test. We only have our s-test, like also, so we can easily copy this and we bring it down here. Then we change this to s-test. You know why we are having it like this is because when you come to our s-test, we just find our s-test. We only need this and this. So we only have to scale just 30.0 and the 54 point, which is the age and the salary. So this is what we are scaling in the s-test. So that is why we are using the same thing for the history, except we are not going to use the fit, because using the fit we are not going to get the accurate figure of what we have. So the only thing we just have to do is make it equal to our XC dot transform. So we're only going to transform our string. Our S test. So that is the only thing we have to do. Then we can just pass this parameter, pass this argument to our data. So this is all what we need. Don't forget to include a bracket here. Don't also forget to include a bracket at the back. So let's run it and see if what we did there is okay or not. Let's wait and see. I think we have some error. And what is the error from scikit-learn? The preprocessing import standard scalar. So what is the problem? No module named scikit-learn the preprocessing. So we are missing one S, I think. So let's run it again. Everything is fine now. So you have to check your typo because sometimes CLs have some typo error. So what should we do now? We are going to print our S. We're going to print our S string. That is the only thing we have to do. Print our S string, then also print our S test. So let's print our S string and see what we have in our S string. Yeah. Now, when you look at it, you can see we've already scaled everything. Now we are having 0, minus 0, minus 1, minus 1, minus 0. So we are having a reasonable number. So one is not bigger than the other. Unlike when we're having it like this, we're having 40, we're having 72, we're having 44. So with this, we will not be able to get a good prediction for our machine learning model. So that is why we have to apply a function scaling to scale the remaining number to make them equal. So we can now print our S module, our S test. So printing our S test. So let's see what our S test look like. Exactly. So look at what our S test look like. Now, I said something earlier. I said we don't have to fit the S test. Let's say, for instance, now let me just try to do some logic here. This just means when you want to hide it, you don't want it to don't run, you can just put hash at the back. Now I want to copy this and I want to copy this and also let me just use s.fit transform and show you what it look like. So for you to see .fit transform, let's see, and let's run our S test. I have to rerun everything together so that we see. Let's rerun all this together. So you can see now using fit transform to the S test. So you can see what we are getting compared to when we used ordinary transform. So we don't have to fit the S test. So we only have to transform the S test. So let's run everything together again and see what we have. So we get back our accurate number. So this is the end of the data preprocessing part 2. Then the next thing I will be doing, we are going to our machine learning in detail. Then we are going to start with simple linear regression. Then in the simple linear regression, we are going to train and we are going to predict our models to see which of the country bought the product and which of the country does not buy the product. Then after that, we move to different aspects of the machine learning algorithm. So we are going to use several machine learning tools to predict our data because we'll be using a different data. Please stay tuned to this channel. You get the best, and your comment also is needed. Please subscribe to this YouTube channel. Let's make it grow and let's share it to people. Let's follow. Let's support for the growth of this channel. Once again, I'm Rock Paul.